Okay, so today we're going to talk about functions defined by equations. So before I get started on actual functions defined by equation, let's review a little bit. So last time we learned that if I give you something like this, okay, last time we learned how to tell whether or not a relation is a function. So take a look at 1 here. I got x, -2, y1, so -2, 2, and so forth. Another way of representing this would be something like this. You know, you have the input box and output box, you know. So, and also, yeah, so is this a function or not a function? Raise your hand if you think it's a function. Raise your hand if you think it's not a function. Very good. Why is this not a function? Put your hands down. How about, okay. Austin, is this not a function, right? This is not a function. Why?
Because it'd be like -2 or -2, 2, -3.
Right?
Same.
Exactly. You have one input that has more than one output, right? Remember, function must have, each input must have exactly one output. So it's not a function. And you could actually graph them, right? Oops. You could graph them. Sorry. You could graph it. Okay. And you can see it will not pass the vertical line test, you see? Or you could like write it as a order pair. So there are 4 ways of representing, right? Set of order pairs, isn't that right? What about this one? So x, y is a table 1, 3, 2, 3, 3, 3, or you could have input box, output box. Is this a function or not a function? How many people say function? Raise your hand. How many say not a function? This is a function because each, how many outputs does 1 have? 1. How many outputs does 2 have? 3. Well, even though it's the same number, it doesn't matter. It has 1 output. So you could, of course, it's a function, and you get a horizontal line. Of course, it passes the vertical line test. You guys remember? So you could actually write this as an order pair. So there are 4 ways, right, that we learned last time of representing set of order pairs. Today we're going to learn another way. So here, okay, y equals to 4x minus 3. Okay, so write this down. So here's a question. Is y equals to 4x minus 3 a function or not a function? But you may say, wait a minute. This is not set of order pairs, as we saw before. It's not a graph. It's not a set of order pairs. You know, it's not a table. It's not in and out box. How come they give you an equation?
What?
Right?
Oh, I thought you said in and out.
Right, the in box and out box. Yeah.
Would you turn it into an in and out?
Yeah, you could actually turn this into an in and out box, or you could also turn this into a graph, and so forth. They got kind of creative here. Instead of then giving you a set of order pairs, what are they giving you? They're giving you an equation. And what does this equation kind of represent? The solution of this equation represents? Yes. Anybody? What does the solution of this equation represent, guys? Even though they haven't given us order pairs, what does the solution of this, by the way, how many solutions are there for this equation? Infinitely many. And what do these solutions look like? They are order pairs. So instead of then giving you order pairs, they're giving you an equation, and they're saying, is the solution to this equation a function? Do you see what I'm saying? Right? After all, the solution to this equation is an order pair, so it's a relation. Right? Isn't this a set of order pairs? Okay. So therefore you have what? A relation, right? Now, is this a function or not a function? Yes? It's a function, correct? How do you know it's a function, guys? Everybody here? No one on this side? I guess one. One on this side. Ryan, what do you think? Is this a function or not a function? Okay. By the way, you're right. How do we know it's a function, Ryan? But first of all, could we graph this if you wanted to? What's the slope of this line? And what's the y-intercept? Correct. So if I were to graph it, don't you get this graph? Right? So we know this is going to be a what, guys? Function. Did you have a question?
This is always a function if it's y equals.
Okay, that's correct. If you have, well, not quite. If you have a linear equation, right? We know from last time that every line is a what? Function except the vertical line. So that's what you're trying to say, right? Good. So this is a function. Because as you can see, it's a line. Now, how come vertical line is not a function? Yeah. It doesn't pass the vertical line test, right? You could draw a vertical line on that vertical line and it's going to hit it more than once, obviously. So this is a function. Okay. Now, what if I asked you this? Find the domain and range of this function. Go ahead, think about what the domain and range are for this function is. Go ahead, I want you to think about it as a group. So, let me ask you this, class. I think a lot of you are already... Can I list all the domain? Is this possible? Why not? Vlad, why can I not list, why can I not like write them down? There's so many of them, there are infinitely many of them, right? So can somebody describe for me what the domain is? First of all, domain is what? All the x coordinates, right? Of these points. By the way, doesn't this line extend forever? So what are all the x coordinates of this line? Can somebody describe for me what that looks like? So we cannot list them all out because can I say 1, 2, 3, negative 1, 2, 3? Is that right? No, what about negative 1.1? What about 1.11, right? What about 1. You know what I mean? There's so many numbers between these. So what does my domain, can somebody tell me what the domain is? What would it be? Can you describe for me what the domain of this function is? So it's a function. Anyone? Is 2 a domain? Is 2 in the domain? Yes or no? No? Yes, it is. 2 is, right, this point right here is 2 comma 5. So 2 is part of my domain, right? Is 1 part of my domain, guys? What about 2? Is 2 part of, I said that. Okay, sorry. What about 0? Is 0 part of my domain? Yeah, right here, 0 comma negative 3. What about 1.1? Is that part of my domain? Yes, it is, right here. 1, if you go a little bit right to the right, a point right next to this, it'll be 1.1 comma, right, something. What about 1.2? Is that part of my domain? What about like 10? Would that be part of my domain? Yeah, this is going to extend forever. It'll have, right? 10. It's going to be 10 point something. I could actually tell you what it is. It'll be 37, right? If you plug in x equals 10, don't you get y value? What about negative 10? Is that part of my domain? Yes. Can somebody tell me what my domain is? What about million? Is that part of my domain? What about negative million? What about negative 2.7? What about negative pi? What about negative square root of 16 or 17 or square root of 18? Anybody see what the domain might be? 2 people? Aaron, what do you think? All numbers? More specifically, which, what do you mean? All of your numbers is your domain. Isn't that right? Wouldn't all your number be your domain, right? Because doesn't this line extend forever, right? So the domain for this line will be all of your numbers. It will have every possible numbers on the number line, right? Well, especially it'll be on the x-axis when we're talking about domain. What about my range? Can somebody then tell me what range might be? Yes. Negative 3 is my range. Why do you say negative 3? It's my range. That's where it hits the y-axis, so is that my range? Well, that's one of them. You're right. It does have 0 comma negative 3. That's one of them. What about negative? What about positive 1? Isn't that my range? Because it's 1, 1 right here. What about 5? Right? This is 2 comma 5. So you can see that's right. But are those 3 points the only range that we have? No. This line is connected and it extends forever. What's going to be my range for this? Yes, sir. All real numbers again. Would you not agree? Right? You give me any y, you could find a point, right, that has that y value because this line goes on forever on both directions. Does this make sense, guys? Any questions? Okay. Let's see if you really got this, because I'll give you some other ones. See if you can figure this out yourself. Okay. I want you to graph. There are 4 points on this. First of all, is this a function or not a function? At this point, it should be really clear. So I have 4 points. This is a set of points, right? Is this a function or not a function, class? This is a function. tell me the domain and range of this function. Go ahead. I'll give you time. List the domain and range. Go ahead. Tell me what the domain and range for this function is. So the point right here is -1 what? What's 2? This is 0, 3, 1, 4, and 3, 5. So who could tell me the domain for this? Again, domain is basically all the x coordinates you're using. Yes, Shemin? That's correct. Isn't that right? It's basically all the x coordinates of. Now, what's a nice way to kind of see this? You could just kind of take a point, go vertically, oops, and you go down vertically, right? This is for this point, right? If you go down vertically, isn't that -1? That's the x coordinate of this point, right? Go down here, that's the x coordinate. Go down here. How do you find the y coordinates of all these points? In other words, what's my range for this? See ya.
2, 3, 4, 5.
Yeah, 2, 3, 4, 5. Another way of looking at it, you could kind of go right across, right? Then if you go across right here, you get 2, 4, 3. It's on y-axis. Here, this is 4. Here is 5, right? Isn't that how you see? Is this easy or hard, guys? Easy? Okay. Then let's try this. This one's a bit different than the one we had. You have a horizontal line. First of all, is this a function or not a function? It's a function, of course. It passes the vertical line test. Can you guys tell me the domain and range for this? Go ahead, everybody try. Okay, so by the way, do I need all these red dot? They're included in this segment, right? So you don't have to worry about those red points. They're included into this segment. So what's my domain? Sarah, what did you write down? How many domains do you think I have on this? What did you write down for your domain, first of all? -2, -1, 0, 1 and 2. What about -3 and 5? Did you include those? Oh, you include. What about 1.1? Is that my domain? What about 1.2? 2.1, 3.1. Right, -2.1. So you can't just write down the integers there, can you? William, what did you write down?
All real numbers between -3 and 5.
All real numbers between -3 and 5 is almost correct. You have to then also say, if you say all real numbers between -3 and 5, that means you don't include -3 and 5. So guess what? You have to say including, including -3 and 5. Exactly right. Do you guys understand? So the reason why we have to say it this way is, why can we not just say all real numbers, guys? Sarah? It's a line segment. It doesn't go on forever, does it? Very good. By the way, there's an easier way to write this. You don't have to write this as a sentence this way. There's another easier way. Does anybody know how to do this using inequality symbols? You could use 2 inequality symbols to. It's called compound inequalities. No? Yeah.
It's going to be greater, -3 greater than or equal to, and then 5.
Kind of. You got the right. It's like this. You use a less than or equal to sign. So you put x in the middle. Why x? Because we're talking about for domain all the which coordinates? X coordinates, right? So x is between -3 and 5, including. How do you show that we're including -3 and 5? We use the less than or equal to sign there. Okay. You guys remember this from intro? We did this, right? So x is between -3 and 5. Instead of writing all this long sentence, you could just use this. Okay, I think I like this better. Does that make sense? So x is between -3 and 5, including those endpoints, right? That's my domain. Does this make sense? Anybody know what my range is then? What's my range? Lisa? 4. This one just have one range, right? 4. Does it have any other range other than 4? No. That's the only range we have, right? Just look at every point on this line segment. The y value is always going to be 4, isn't that right? It has the same height. You can think about it that way. Are we okay? Do you guys get the idea in terms of what the domain and ranges are? Okay. Let's look at the next one. What about example 1D? I have a line segment. First of all, is this a function or not a function?
Not a
It's not a function. Very good. It's a vertical line, right? Or part of it, right? Part of a vertical line. So it's not a function. All the other ones were functions. Okay. And what does this open circle mean? Whereas the other one is closed circle. What's the difference between those two? Yes, sir.
Include the dark circle and
That's right. Here I am including the point -2, -2, right? Do I is -2, 3 included in this relation? No, it's not. But what about -2, 2.99999? Yes, that's included, right? Anything really, really close to 3, but not 3, right? That's what that open circle means. Do you guys understand? Okay, so go ahead and write down the domain and range, please. Whoops. Sorry. Not that. Anyway, go ahead. Try domain and range. All right, Viviana, what did you say for your domain, first of all? -2. Are there any other x values that we use other than -2? No, that's it. So that's easy. Because look, every point on this line segment, right, has the x value, right, x coordinate of -2. There's no other x coordinate. Right? Otherwise, it won't be on this vertical line. Secondly, what's your range then? How would you write your range? Anyone? No one knows what the range for this? One person? Sarah, hey, what did you write?
For the range,
Uh-huh.
all real numbers between 3 and -2, including -2.
Right. So you don't have to say not including. So all real numbers between -2 and 3, including -2. So if you don't include it, then it's not included. Right? What's another way of writing this? Using this, yeah, Melissa?
-2,
Less than.
less than, not and x, then less than, or equal to.
Oh, so you, oh yeah, yeah. But you said x or y. Do we need to put x or y in the middle? It's y because we're talking about range. Okay, so be careful. It's y. Okay, so, all right. So you're right. So it's the way you read it, guys, is you read the y first. Y is great. Y is between -2 and 3, including -2, which is what we just wrote down up there. Okay, so that's how you write the range here. Does this make sense? Do you guys get the idea?
Yeah.
Is this easy or hard? Okay, good. I hope so. Okay. Let's look at the next one. Okay, go ahead. Try the 1E. Now, I have a segment that looks like this. Go ahead, tell me the domain and range. By the way, is this a function or not a function, class? Function. This everybody should know about this. Okay, it's a function now. Okay, go ahead. Everybody tell me the domain and range. Somebody tell me the domain for this this function. One person? Two? Kaylin, what do you think?
Okay, it's all real numbers between -2 and 4, including -2.
That's correct. All real numbers between. So I wrote it this way. Is that okay? So all real numbers between. Right. Good. Oh, yeah. That's how you read it too. Very good. All real numbers between -2 and 4, including the endpoints. Okay. What about for the range? How about Stefan? What do you think?
I got all real numbers between -2 and 3.
-2 and.
3.
Where'd you get -2 and 3 from? You have a point that has -2. Okay, say it again. What is it? Okay.
All real numbers between 3 and 5.
3 and 5. Very good. Including the. Including the endpoints, right? Okay. So, by the way, do you guys see this kind of? Let me show you a little trick that I do. Look at. If I was to look at this segment, look at all the x's being used. Well, if you were to, I don't know, if there's a light up here, if you were to cast a shadow onto the x-axis, wouldn't these points be your domain? If you had lights on the two sides, wouldn't it cast shadow over here? Aren't those your range? Right? It's kind of easy to see. Once you have a graph, right? Basically, that's what they are. Do you guys see that? Okay, just right. All the x. Look at all the order pairs that's being used. Well, it's got to be all the x's right down here. Look at all the y's that's being used. It's got to be between these, right? These points, right? Otherwise, it won't be on that line segment. Any question? Are you good? Okay, good. So example 2, you have something like this on your homework tonight. List the range of y equals to 2x minus 4 if the domain is 0, 1, 2, 3, and it asks you to graph. So is this a hard problem or an easy problem? This is easy. Basically, what are they asking? Somebody know? Does anybody know what they're asking here? One person? Two? It says give the range. What do you think? Yeah.
Find the y.
Exactly. Find the y's when x is equal to 0, 1, 2, 3. Does that make sense, guys? And do we know how to find y's for these? Yeah. You do a chart or table. Go ahead, everybody. Yeah, substitute. Okay, go ahead, everybody. Okay, so did you all do a little chart and got -4, -2, 0, 2 for your range? Yeah? Isn't that right? When you plug in x equals 0, right? You just do a chart. And you should have all gotten a bunch of 4 points, right? You got, you have 0, -4, 1, -2, 2, 0, 3, 2, right? Is this a function?
Yeah.
Yeah, it's a function. Okay, any question? Easy enough? Okay, good. Let's move on. So I'm going to ask you a very similar question as what I just did before. For this function y equals to 2x plus 4. Can you tell me, I'm sorry, can you tell me the value of y when x is equal to 0? Which is kind of the same question I asked before, isn't that right? So this is kind of easy. Can somebody tell me what the value of y will be? 4. Everybody. Okay, 4. I didn't write it down. But can you do it for these? There are 3 questions. Actually, oops. There are, yeah, 3. Yes, but oops. Right, they're really easy, aren't they? But I'm trying to make a point here. So go ahead, write this down. It says B says what is the value of y when x equals to 2? C, what is the value of y when x equals to 3? Go ahead. What's the hardest part of this question? Or what's the part that takes the longest? Actually, writing down the question. You said it, Austin. That's exactly right. Because do you know how to find the value? So first of all, what's the value of y when x equals 0? We said it was 4, right? Okay, so you get 4. Hold on a second. So did you get 4 and 8 for the second one? What is the value of y when x equals 2? C, what is the value of y when x equals 3? 10, did you all get that? Okay, so I'm trying to make a point. The hardest part, or the longest part of this question is actually writing down the question, right? You see how it takes so long to actually say, what is the value of y when x equals to whatever, right? So, you know, in math, we came up with a nice notation called function notation. So, so because it took so long to ask this simple question, we came up with a function notation. Okay, it's called function notation. Does anyone already know what that is? So let's look at A. Instead of me writing this whole sentence, they have come up with this notation called function notation. Do you know how to do that? Yeah.
It's f of x.
Yes, very good. We use this notation, we write this. You see this whole sentence? It could be done by just writing this is how we read it, f of x. So instead of me writing what is the value of y when x equals 0, this says the same thing. When I say f of x, we have decided, okay, this is what we mean by when you plug in x equals 0, what do you get for your y? Does that make sense? So what's the answer, by the way? We already did it. It is 4. Right? Do you guys get what we're trying to say? So that's what I'm trying to make a point of. Okay, because it's so long to ask this sort of question. This is a very simple question, right? We just want you to plug in x equals to 2 here. What do you think then this will be? What is the value of y when x equals to 2? How would you use this function notation? Yeah, Melissa. F of 2. Exactly right. So when I say this, f of 2, this is what it's that question, exact question. What is the value of y when x equals to 2? And what's the answer? 8. Didn't we just find that answer? Okay, Austin, guess what the third question will be written as? Instead of writing this long sentence, what is the value of y when x equals to 3? What do you think we're going to write? F of 3 is exactly right. Does that make sense? So then, what's the answer? 10. Do you guys understand what I'm trying to say? Is this easy or hard? Let me ask you this. What is the value of y when x equals to x? How would you write that? What is the value of y when x equals to x? Yeah?
F of x.
Yeah, f of x, exactly. And we know what f of x is, right? What was f of x? Right here, 2x plus 4, right? Isn't that how you get f of x? Whatever the x is, you multiply that by 2 and add 4. So, to go from regular equation to function notation, all you have to do is what? Instead of writing y, you write f of x. That's it. Any question? Does that make sense? You see how convenient this is if you use something as function notation? Okay, if you have a function, you could use function notation, okay, to get, instead of writing this whole sentence, you could just make it a lot easier. Any question? Okay, let's see if you really got it. Let me give you some examples. And you know, I always want you to write the work. So if you wanted to show a work for f of 0, right, you plug in 2x, right, times, it was 2x plus 4. So in place of x, you plug in 0, right? And this is how you get 4. Does that make sense? So that's the kind of work that I want to see. I don't just want you to write this on the right side. You know what I mean? I want to see this work. Okay? Does that make sense? Okay. Anyway, so on your homework tonight, they're going to ask you, so we have a function, y equals to x squared plus 1. We have this equation. They're going to ask you to rewrite using function notation. Does anybody know how to do that? Gemma? Oh, interesting. Anybody? Look at what we just did. Victor?
Wouldn't you do f of x equals x squared times x plus 1?
X squared plus x plus squared plus 1. Right? Say it again. What?
F of x equals x squared times x plus 1.
Times? Where do you see times? X squared plus...
Substituting the f of
No. So this is a separate question. If I had this equation, what would this be in as a using function notation? How would you write this using function notation? You just write?
f of x equals x squared.
Yeah, exactly. You just replace y with f of x. Is this hard or easy? Okay, that's it, okay? And, of course, after you do this, they're going to ask you to find f of 0, f of 1, f of negative 1, f of 2, f of negative 2. Okay? So, I'll do one for you, f of 0, okay? How do you do okay, how do you do f of 0? Well, you plug in instead of x right here. By the way, does this mean f times 0 so you get 0? No, please don't think that it's f times 0. It's saying notation, okay? It's saying plug in x equals to what now? 0. So when I do, here's the work. When I'm plugging in x equals 0, I get 1. Right? I wrote down y equals because that's the value of y, isn't that right? Do you guys understand? Okay. Can you do the rest now? Go ahead, do the rest. B. Who has B? How about, let me call somebody around. Eddie, what'd you get?
F equals
2. And what kind of work did you show?
I plugged in 1 for x.
Exactly.
And multiplied that. I got y equals 1 plus 1.
Perfect. There you go. William, what'd you get for f of negative 1? 2. Also, right? Because if you plug in negative 1, you have to square it, so you get 1 again. Don't you guys? And you get 2. Paul, what'd you get for f of 2? Yeah. 5? Okay, you're right. How'd you get 5?
2 squared plus 1.
Exactly. 2 squared plus 1, 5. Now, William, what'd you get for f of negative 2? 5 again because you, yeah, negative 2 squared is positive 4, right? So, is this easy? Okay. By the way, let me see if you really got it. How about, I haven't done this before, but what will be the order pair? F, x, comma, y. Because aren't these functions, well, relations, set of order pairs? So what is the order pair for this one? And when I say f of 0, I got 1. Let's see if you got really understood. 2 people see it? 3? Well, what do we plug in for x, for a? We plug in x equals to 0. So guess what goes here? 0, comma, what's your y? 1. So instead of y, what else could I write this as? This is really x, comma. I could write f of y. Okay, anyway, what about this one? 1, comma. Hold on. 1, comma what? 2. Negative 1, comma. 2. 2, comma. 5. Because this is a relation, right? They're set of order pairs. Negative 2, comma. So what is this really same as? X comma what? Instead of y, I could write this as x comma f of x. It's exactly right. Because f of x is, after all, what? Y. Very good. Do you guys get the idea? Okay. So this is important. When you do your homework tonight, this is going to be important today. Okay? Any question? Do you understand? It's just different way of saying the same thing. Okay. All right. Good. Okay. So what if I gave you this, class? Let me step it up a little bit and ask you these. F, it says f of 2 minus f of 1. G says f of 3 minus f of 0 over 3 minus 0. H says f of negative f of 2. I says G now of f of 0. Go ahead. See if you. Let me see if you really got understood. Go ahead. Try these. So try f and g first, okay? We'll do the other two later. Okay, go, at least try these two first. Go ahead. So first of all, did you all understand that f of 2 is nothing more than you plug in 2 for x here? So you get, well, we did this before, didn't we? F of 2 came out to be what, guys? 5 minus, what's f of 1? 2. What's the answer? That's it. That's all we're asking you to do. Here, what was f of 3? Well, you plug in 3 here, you get 3 times 3 is 9, plus 1 you get 10 minus, what's f of 0? You plug in 0 here, you get, class? What's f of 0? 1 over, what's 3 minus 0? 3, which is? 9 over 3, which is? Okay. Does that make sense? Now, what about h? Any question for, first of all, f and g? Does that make sense? What does f of 2 mean? Anybody? Yes, Alvin.
So you do the f of 2.
Yeah, you do f of 2 first. After all, what's f of 2? It's a number, 5. So you get f of, right? When you plug in 2 here, don't you get 2 squared plus 1? Don't you get just f of 5? So this is another way of asking f of 5. That's all. Could we figure out what f of 5 is, class? What is it? What's f of 5? 26. Because it's 5 squared plus 1. Does that make sense? Right? Yes. Okay. Do you know what? Okay, so forget about what's outside. Look at inside. Do you know how do you get f of 2? No? Were you able to get f of 2 from here? Yeah, so what's f of 2? Same way. You plug in x equals 2, what do you get? Because we're looking for f of 2 first. Because inside the parentheses, right? Okay, hold on, guys. Wait. May I have your attention? Class? Okay, what's your question, Melissa? Say it again. No, they're the same equation. I'm using the same f of x. So when I take f of 2, do you see how I get 5? Just like how I got 5 before? No, what does f of 2 mean? You plug in 2 for x, and you get the y value. What do you get when you plug in 2? You get 2 squared plus 1. What is that? Isn't f of 2 equal to 5? Let's go back. Guys, listen. Isn't f of 2, look, didn't we do f of 2? What do we get? 5. So in place of, I'm just using substitution here. In place of f of 2, I just write 5. And now I am now looking for f of 5. Right? How do you find f of 5? We do, well, f of x was what? X squared plus 1. So now f of 5 will be 5 squared plus 1, which is 26. Does that make sense? Okay, if you got this, everybody try I now. See what you get for I. This time I am using another function. It's called g. Okay, you don't have to use f every time. If you're referring to different function, guys, listen. If you're referring to different function, you can use different letter. Go ahead, try this now. All right, so who could tell me how to do I? One person. That's it? One person? Oh, what about Benjamin? What do you think?
You plug in the 0 in the f of x.
Good. I plug in. I need to find this first, right? After all, f of 0 is some number. So when you plug in 0, what do you get, Benjamin? G of
1.
Good. So now, do you know how to find g of 1, guys? Now, do I use the same function, or now do I need to go to a different one? Different one, right? Like I said, there could be different functions, okay? So there could be g of x, it could be h of x, right? Now, when I plug in 1 here, what do I get? What's 1 squared plus 3, class? 4. Oh. Isn't that 4? Does that make sense? Any question? Are we good? How many people are pretty clear? Raise your hand. How many people are not so sure? Okay. Try this one. And try this one now. Let's see if you really got this. J. We're using the same functions as before. Try this one. Yeah, it's the same. It's different. It's actually. It looks similar, but it's different. Let's see if you actually understood the previous one. If you could do this one here, okay, you should be fine. Go ahead, try this. By the way, some of you asked me, why do I have to name this g of x? Why can I not use f of x again? Would that be a good idea? No. Why not? Somebody raise your hand and tell me why. Why is it not a good idea to use same f of x on this one? William? Yeah, we have different equation. If it was same f of x, they should be the same thing, right? You can't, right? That's why I have. Now, what does g of 0 mean? It gives you a number. It gives you the y values for when I plug in x equals to 0, right? What do I get, guys, when I plug in 0 of 0? 3, right? Because 0 squared plus 3, isn't that 3? So basically, I'm asking f of 3, am I not? Do we know how to find f of 3, guys? What is it? 10. Okay. Any question? Does this make sense? Okay. So let me ask you this. I would like you to find, there is 2 parts, f of 0 and solve f of x equals to 0. They look very similar, but for a f of x this way, okay, so you don't need to. So if f of x equals to 3x minus 12, can you find A, f of 0, and B, solve for f of x equals 0? Go ahead. Think of this. And they look very similar. Okay, but think about this problem, because you will see this on your homework and on your test. What do they mean by these 2 things? They're not the same thing, okay? Even though they look very similar. So, guys, f of 0, we've been doing f of 0 before. What is f of 0? You plug in x equals to 0 and you get 12, right? So that's not a problem, right? But then, what's this? F of x equals 0. What's the difference? Raise your hand if you think you know. Yes, Ali? Kind of. What do you mean by that?
I mean, like, after you do all the work
right.
that you require from that one, that's the answer.
That's right. So, what is it that this B part is asking? Anybody? She's correct. Can anybody want to add something to that? Make it a little bit more clear. What are they asking when they say f of x equals 0? Are we trying to find what this f of x become? No, we know what it becomes. It becomes 0. What are we looking for then? What do you mean by that? What it was. In other words, what is this second part asking? Solve. Yes, sir.
Isn't y equal to f of x?
Yeah.
Then wouldn't you substitute f of x as wouldn't you substitute y as f of x and then you substitute into the slow form?
No. What do you think it's asking?
So it's basically 3x minus 12 equals 0.
That's exactly what it's asking. Did you hear what it said? Say it again.
3x minus 12.
Yeah, it's asking. Say it louder.
3x minus 12 equal to 0.
Yeah, it's asking which values of x, right? It's asking which values of we were looking for the value of x. Here, I gave you the value of x, right? Here, I'm looking for value of x that makes this whole equation equal to 0. So, we're asking, when will 3x minus 2 equal to be 0? And when does it, which x makes this whole thing equal to 0? 4. How do you know it's 4, you? Well, here you could kind of do it in your head, but if you, some of them you couldn't. You can't. So you add 12 to both sides, then what? Divide by 3, you get 4. So this here, that's why it says solve, right? You are looking for, guys, listen. You are looking for the value of x that makes this whole equation equals to What? 0. Does that make sense? Hello? Question?
Like when I went first there, I feel like F of 4 because like if you did that, you can like substitute 4 in the X.
Right.
What would the answer just be root X equals 4?
So,
Like the final answer.
yeah, the final answer is x equals to 4. That's what the final answer for B is. Guys, pay attention now. This is important. Does this make sense? So let me ask you this. What is the order pair that we got for A? Somebody tell me. What's the order pair? We plug in x equals to what? 0 and we got? Negative 12. Okay, what is the order pair that we got on this one? What do we plug in for x? 4 and we got? What do we call this, guys? This is the X Intercept. How do you find X Intercept, guys? You plug in? Oh, is this X Intercept or Y Intercept? This is, this is a Y Intercept. The F of 0. I'm sorry, this is the Y Intercept. Guys, to find the Y Intercept, what do we plug in for 0? X. What's this? This is your 4, 0. Where is this on? Where is this on the graph? X-axis, right? What is this called? This is the X Intercept. How do you find X Intercept? You plug in 0 for Y. For Y Intercept, you plug in 0 for X. So this question is really asking, when you say F of 0, what are you actually looking for? This is the well, F of 0, it gives you the Y intercept. If you're looking for F of X equals 0, then you're looking for the X intercept. Does this make sense? Guys, this is important, okay? Do you understand what this is asking? F of X equals 0 means they're looking for the value of X that makes the Y equal to 0, right? What is that called? That's your X intercept. Hello? Yes? Question? So listen. So the y-intercept is nothing more than 0, comma f of 0. Would you not agree? Right? Isn't that what your y-intercept is? Okay.
Okay.
Right? Alright, so anyway, now let me show you some facts about what we just talked about. Fact. What's another way of writing this equation? Y equals to mx plus b using function notation. So it's kind of a summary. Yes, Black? F of x equals to? Yeah, mx plus b, right? Now, does it have to be f? Could I use g of x, h of x? Yeah, it doesn't matter. But I like to use f for function. Okay, but it doesn't have to be f. Now, there's actually another on your book. It actually has an arrow notation. It's really nothing more than the same thing, except here they just use this. Instead of equal sign, they use arrow. Do you see any? Okay, so if you see arrow, don't get scared. It's just the same as before. And instead of parentheses, they use what? Colon. That's all. Okay. So if you ever see that, it's the same thing. Okay. You could just rewrite it as f of x if you like. Do you understand? So don't be, scared just because they have arrows and colons. Okay. Any question? Does this make sense? Okay. So for example, y equals to 2x plus 3 could be rewritten as what? F of x equals to what? 2x plus 3, or f colon x arrow what? 2x plus 3. Does that make sense? Okay. Are we good?